Welcome to the keynotes video for this week. This indicates the notes you should probably be writing in your book. Some of these notes will have already been written on the board when we explained it to you at the start of the lesson. So acids and bases is our big heading for the week. Next week we're going to have a look at what happens when an acid meets a base. Okay, and basically, before we have a look at acids and bases, we're going to have a look at pure water. And in water, 1 in 10 million water molecules will split up into ions. What that basically means is with water, 1 in 10 million, which is 10 to the power 7, will split up into an H plus and an OH minus. The rest will stay stuck together. We say water has a pH of 7. Because it's 1 in 10 to the power 7. An acid is a substance that splits into H plus ions more than water. So more than 1 in 10 to 10 million. So e.g., hydrogen chloride gas, when dissolved in water, will split up into an H plus and a Cl minus. Okay. So that in an acid there are many more floating around, which means the H plus ions are very reactive. Because if you think about it, they're basically bare protons. Okay. Strong acids imply every molecule splits up, thus liberating lots of. In a weak acid, only some split up. Oops. Okay, let's go on to bases. Bases have more hydroxide ions floating around than pure water. Remember, pure water had 1 in 10 to the power 7. So e.g. our famous base sodium hydroxide, NaOH splits up into an H plus and an OH minus. Strong bases implies all base molecules split up. In a weak base, only some molecules split up. Carbonates can also be bases. For example, sodium carbonate, sodium hydrogen carbonate. Even though it's got an H in it, it's still a base because it ends in a CO3, which is a carbonate. So we have bases and we have acids. The next question is what happens to compounds that are neither bases or acids. So we'll go on to a new slide for that. Call these salts. If they are made up a positive part cation and negative part. So we have the idea of a salt. Before we look at the pH scale, which is the final thing we're going to look at today, we need the idea of what these four words mean. Strong, weak, concentrated, and dilute. Because they mean different things. Strong means all split up. Weak means only some of it is split up. Concentrated means lots of it in the water. It may not be split up though, but there's lots of it in the water. And the final one, dilute, not much in the water. Okay, now we're going to go into the pH scale. Okay, our pH scale goes between 0 and 14. In the middle in 7. It's not quite the middle, I'll rub that out and do a better middle for you. That's about the middle. 7 is where we have pure water. This is the acidic side, and this is the basic side. Now clearly, the more stuff we've got and the more it splits up, the more acid it's going to be. And so that, for example, our strong concentrated acids are going to be right at this end. So got to be both strong and concentrated. Our strong concentrated bases are going to be at the other end. If I had on the scale, say, something at 5, what that basically means is that 1 in 10 to the 5 molecules are split up. And something else. That's how we interpret the scale. It's a bit harder to see how the scale works the other way with the bases, because it turns out the more base you have, the less H pluses you have floating around, but it's the OH minuses at that point that are the dangerous bit. So if it was 4, it would be 1 in 10 to the power 4, 1 in 10,000. 3 would be 1 in 1,000. pH of 2 would be 1 in 100. pH of 1 would be 1 in 10, and pH of 0 would mean everything's split up and it's fully dissolved in the water, so virtually everything is the acid molecule. With a base, if it's 14, it means there's a maximum amount of OH minus ions floating around, which means there's a minimum amount of H plus ions floating around, and there's only 1 in 10 to the power 14 H plus ions floating around because there's heaps of OH minuses. The idea is that as you go further away from the middle, the more dangerous it gets. A weak acid's never going to have a pH of 0, because even though there's lots of it there in a concentrated solution, it's not all going to be split up. So to have a pH of 0, there's got to be lots of it, and it's got to be all split up, which is why it's got to be both strong and concentrated. Okay, there are your notes for this week.